Hey folks, in this lecture we will build a fully working snake game using Python and Pygame. We'll create a game window, draw the snake, move it across the screen, make it grow when it eats food, and even end the game if it hits a wall or itself. To make it more exciting, we'll also add background music and an image to bring our game to life.
Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Let's get started. So, here we have already opened the PyCharm IDE. In the left panel, you can see three files added to the project folder. The first file is a sound file named background.mp3 that we will use as background music for our game. The second file is an image file named background.jpg, which will be used as the game's background. You can see a preview of this background image opened on the right side of the screen. It shows a wooden texture with some green leaves, giving our game a natural look. The third file is main.py, which is our Python code file. This is where we will write all the game code step by step. These three files must stay in the same project folder. Now everything is ready to start creating the game. Let's move on and create our main game window. Since we already learned how to do this earlier, we just pasted the code here to save time. Let's take a moment to explain this code first. At the top, we start by importing the Pygame library and calling the Pygame init function to activate all the built-in modules that Pygame needs. Then we set the width and height of our game screen using two variables, width and height. After that, we create the window using pygame.display.setMode function and pass in the screen size. This creates a window that is 640 pixels wide and 480 pixels high. Next, we set a title for the window using pygame.display.set-caption function with a title, Snake Game, so the top bar of the window shows the name of the game. After that, we start a while loop with a running flag that keeps the game window open until we choose to close it. Inside this loop, we check for any events using Pygame event get function, and if the user clicks the close button, we set running to false to break out of the loop. Finally, we call pygame.display.update function to keep refreshing the screen every cycle. And when the loop ends, Pygame quit function is called to properly shut down the Pygame engine. Let's run this code now. Here you can see the game window opens with the title Snake Game and stays open until we click the cross button. This is our first working game window. Now let's move on and go after the screen setup. Here we are now adding two important things, the background image and background music. These are very useful because they make the game more interesting, colorful, and enjoyable for the player. For this, we use the function pygame.image.load and pass the file name background.jpg as a parameter. This tells the program to load the background image from our project folder. We store this image in a variable named background. After that, we use another function called pygame.transform.scale. This function resizes the image so that it fits perfectly into our game window. We pass two parameters inside this function. The first one is the image we already loaded, which is stored in the background variable. The second is a size tuple that uses the same width and height that we set for the window earlier. This makes sure that the background fills the full screen area. Then we use the function pygame.mixer.music.load to load the music file we added in our project. We pass a background.mp3 as a parameter to this function. This tells Python to prepare the background music for playing. After loading it, we use the function pygame mixer music play to actually start the music. We give it -1 as a parameter, which means the music will keep repeating in a loop and never stop until the game is closed. Now we go inside the while loop to make our background image actually show up on the screen during the game. For this, we use the function window.blit function with the background variable as the first parameter, which means we want to show the image that we loaded earlier. The second parameter is a pair of numbers 0 and 0 to tell the program to start drawing the image from the top left corner of the screen. This is very helpful because we want the background to stay visible all the time while the game is running. If we don't put this function inside the loop, the background will not refresh on the screen, and it may disappear or not appear at all. Let's run it. Here you can see the wooden background fills the game window, and the background music starts playing in a loop. This makes the game screen look alive and sound more engaging for the player. Then we go outside the loop, and here we create two colors because we are going to do two things in our game. First, we will make a snake that appears in green, and second, we will make a target or food that the snake eats, and that should appear in red. For this, we create a color variable named green using the RGB value 0, 255, 0, which means full green and no red or blue. Then we create another variable named red using the value 255, 0, 0, which means full red and no green or blue. These color variables will help us easily use colors while drawing the snake and food later in the game. After that, we prepare the size and starting positions for the two most important parts of our game, the snake and the food. For this, first we create a variable called snake block and give it the value 20. This number means each block or square of the snake's body will be 20 pixels wide and 20 pixels tall. Then we create a list called snake watch list and add one set of values inside it. 320 for x-axis, and 240 for y-axis. This means our snake will start from the middle of the screen. Next, we create two more variables named food x and food y. These values are used to place the red food on the screen, which the snake will try to reach and eat. The x position is set to 300 and the y position is 200. These fixed numbers help us see the food on the screen when the game starts. So this part of the code sets the size of the snake, its starting location, and the location of the food, all of which are needed before we start moving things on the screen. Now we move inside the while loop again because we want to draw the snake and the food on the screen while the game is running. First, we use the function draw.rect from the Pygame module. Here we use pygame.draw.rect with the window variable to choose where we want to draw. The second parameter is red, which is the color we want for the food. The third parameter is a rectangle defined using food x and food y for the position, and snake block twice for the width and height. This creates a small red square that will work as our food. After that, we use a for loop to draw the snake body. Inside this loop, we go through each block inside the snake list. Then again, we use the pygame.draw.rect function. This time we use green as the color, and the block's position is defined using block index 0 and block index 1, which means the x and y values. The size is again set using snake block for both width and height. This makes a green square that shows our snake on the screen. Let's run it. Here you can see the green block representing the snake and the red block representing the food. Both are drawn on top of the background image, and the screen is now starting to look like a playable snake game. But right now, the snake is not movable and it's not under our control. it just stays in one place without reacting to any key press. That's because we haven't added any movement or input controls yet, which we'll do in the next step to bring the game to life. Let's move on and make the snake movable. For this, we first go outside the loop and create two variables named x1 and y1 and set them to 320 and 240. These numbers define the snake's current position on the screen, starting from the center. Next, we create two more variables called x1 change and y1 change and set them both to 0. These will be used to control the direction in which the snake moves. At first, we keep the values 0 so the snake doesn't move until the player presses a key. After that, we make a variable named clock and use the function pygame.time.clock to create it. This clock helps control how fast the game runs. It limits the number of times the game screen updates in 1 second, so everything moves smoothly and doesn't go too fast. This step prepares us for adding keyboard controls and updating the snake's position later in the loop. Then we go inside the for loop, which is placed inside the while loop, and now we want the snake to move when the player presses a key. For this, we use key down from Pygame. It helps us to check if any key was pressed during the game. After that, we use event.key to know which key was actually pressed. Now we look for arrow keys, left, right, up, and down, because we want to move the snake in those directions. If the player presses the left arrow key, we want the snake to go left. So we reduce the value of x by using a negative number. Here we change the variable x and change to negative snake block. This means the snake will move 20 pixels to the left every time the screen updates. At the same time, we set y1 change to 0 so the snake does not move up or down, only left. If the player presses the right arrow key, we want the snake to go right. So we set x1 change to plus snake block to move right 20 pixels each time. Again, we keep y1 change 0 to make sure the snake doesn't move up or down while going right. Now, if the player presses the up arrow key, we want the snake to go upward. That happens when we reduce the y value. So we set y1 DOS change to negative snake block, and we keep x1 DOS change 0, so the snake doesn't move sideways during this upward movement. If the player presses the down arrow key, we want the snake to move down, so we increase the y position. That's why we set y1 shall change to plus snake block, and x1 shall change is kept at 0, so there is no sideways movement while going down. Then we go outside the for loop but still stay inside the while loop because we now want to update the position of the snake on every frame of the game. The for loop is only used to check the events like key presses, but the while loop is the main game loop that keeps running again and again. This is where we constantly refresh the game screen and update positions. So here we add the values of x1 change and y1 change to x1 and y1. This is done using the equals plus operator, which means we are increasing the x and y positions of the snake step by step. These changes depend on which arrow key was last pressed. By doing this, the snake moves forward in its current direction with each pass of the while loop. This is very important because it creates the actual motion. If we added this inside the for loop, the snake would only move once per key press. But inside the while loop, the snake keeps moving without stopping, just like a real snake game. Now we update the code to make the green snake move instead of staying fixed. For this, we replace the old for loop that was used for blocks in Snakefish list with a new draw function that uses updated x1 and y1 values to show the moving snake block on the screen. This change is needed because earlier the green snake was drawn at one place from the fixed snake list, and that list was not updated, so it didn't really move. But now we use pygame.draw.rect with the window variable, the green color variable, and a list containing x1, y1, snake block, and snake block as parameters. These values make the green square move based on arrow key input, which we coded earlier using x1 change and y1 change, but this single rectangle with x1 and y1 just for testing the movement of the snake. Later, we will change it back to the for loop with snake ear list so we can make the full snake grow and follow its body. After this, we go after the update function. And here we use the clock.tick function with value 15 as the parameter. This tells the game to update the screen 15 times per second. If we don't write this, the game becomes too fast and unplayable because it runs at the full speed of the computer. So this function is very useful to slow down the game to a smooth speed that looks nice and can be played easily. Let's run it, and here you can clearly see that now we can control the green block with arrow keys, and it moves slowly across the wooden background. But right now, the green block only moves around the screen when we press the arrow keys. It doesn't check if it touches the red food square, and it also doesn't grow longer after eating. The snake size stays the same. Now, to make the snake grow when it eats food, we first need to set up a list that will keep track of each block of the snake's body. So let's move out of the while loop, and here we create a variable named snake.list and set it as an empty list. This will store the positions of all parts of the snake's body as it moves. We also create another variable called length of chore snake and set it to 1 because at the beginning the snake will only have one block. These two variables will work together. Every time the snake eats food, we will increase the length of scare snake, and snake list will automatically grow. This will allow the snake to get longer as the game goes on. After that, we go inside the while loop again because now we want to keep track of the snake's movement and update its body in every frame. So here we first create a new variable called snake.head and assign it a list with the current x1 and y1 values. This gives us the head's latest position. Then we use the append function on the snake list to add this head to the list. This makes sure every new position of the snake is saved and shown on the screen. But we also need to manage the snake's length. So we write a condition that checks if the length of the snake Nash list is greater than the value in length of dash snake. If it is, we remove the first block using del snake list with index 0, which keeps the snake at the right length unless it eats food and grows. And then we go ahead and check if the snake hits itself. For this, we use a for loop that goes through each block in the snake list except the last one, which is the current head. We use the slicing snake swirl list with :-1 index to skip the last block. Inside the loop, we compare each block with the current snake head. If any block has the same position as the head, it means the snake has touched its own body. In that case, we set running equals false to stop the game loop and end the game. This step is important because it adds the rule that the snake should not crash into itself, just like in a real snake game. Then we go further and check if the snake eats the food. For this, we compare the current snake head position with the food position using the variables x1 and y1 for the snake, and food x and food y for the food. If both x and y coordinates match, it means the snake has reached the food. Inside this block, we generate a new position for the food by using the Pygame time getTicks function. This gives us the time in milliseconds since the game started, which we then convert into a valid position inside the screen by using modulo with screen size dividing and multiplying to make sure the food appears on grid positions. After placing the food in a new spot, we increase the length of a snake by 1. This makes the snake grow longer with each bite. After that, we add the for loop again because now the snake is made of multiple blocks. Before, we only needed to draw one green block using the x1 and y1 variables. But now, every time the snake eats food, we add a new block to the snake match list, which stores all the positions of the snake's body parts. So we use a for loop to go through each item in the snake list. Inside the loop, we use the pygame dot draw dot rect function with window, green, and the block position to draw each block of the snake one by one. This makes sure the full snake, head and growing tail, is shown correctly on the screen. Now let's run this. Here you can see the green snake is moving when we press the arrow keys, and we can easily control its direction. Also, you can clearly see it eats the red food and becomes longer each time, which means the snake is growing as expected. But as of now, the game does not end when the snake hits the wall. It just keeps going, so we still need to handle that part. For this, we move outside the while loop because we want to define a helper function that we can use anytime the game ends. For this, we go outside the while loop because we want to create a function that shows a message when the game ends. This message should appear only once when the snake hits the wall or itself, so it should not go inside the loop. First, we create a font using the pygame.font.sysfont function. This function allows us to choose the style and size of the text we want to show. We use none as the name, which means it will use the default system font, and we give it a size of 35 to make the text big and clear. After that, we define a new function called showMessage. This is a custom function that we can call later to show any message like game over or you win. This function takes two inputs, the message text and the color we want to use. Inside the function, we use the font render function. This function turns our text into a picture that we can draw on the screen. It uses the text and color we give it. Next, we use msg get rect to get the size and position of the text message. Then we center the message on the screen by setting the center point using width, floor division 2, height floor division 2. This means we divide the width by 2 and only keep the whole number part, no decimal. For example, if the width of the window is 640, then 640 by 2 gives us 320. We do the same for the height. So height by 2 means divide the height by 2 and take the whole number. If height is 480, then 480 by 2 gives us 240. This makes the message appear in the middle of the game window. Finally, we use the window dot blit function. This function draws things on the screen. Here, we use it to draw our message using the message surface and its position. After that, we set game-close equals true. This means we are telling the program that the game should now move into the closing or game over state. The word game close is just a variable name we use to control what happens next. When it becomes true, the game understands that something has gone wrong, like the snake hitting the wall, and then now it's time to stop the main game and show the game over message or wait for the player to restart or quit. After that, we go inside the while loop again because now the game is in a new state. We already told the game that game-close equals true, which means something bad happened, like hitting the wall. And now we want to show the game over screen or give the player a chance to quit or restart. Inside the loop, we write the part that checks if game close is true, and then we show a message like game over or something similar. We also wait for the player to press a key like Q to quit or C to play again. So we go back inside the while loop. But now we are in a special loop for game over, not the regular game loop. That's why we go there, to handle what happens after the snake dies. It helps us show the final screen and listen for the player's next choice. Now we go after the clock.tick function, and here we create a new while loop. But this loop is still inside the main while loop, so it's a nested while loop. This new loop only runs when game close is true, which means the snake has already died, maybe by hitting the wall or colliding with itself. At this point, we don't want the snake to keep moving, so we pause the actual game and enter this special loop to display the game over screen. So first, we redraw the background using window.blit function to clean the screen. Then we call a custom function named showMessage, and we pass a message saying game over. Press C to play again or Q to quit. This message appears in red color and tells the player what just happened and what they can do next. After that, we call pygame.display.update function so the message actually appears on the screen. Without this update, nothing new would show. So this whole part is for stopping the game, showing a clear game over screen, and waiting quietly for the player's next action. After that, we create a for loop inside this second while loop because now the game is in game over mode and we need to listen for the player's input. So here we write for an event in the pygame.event.get function. This means we are checking all the events that the player is doing, like clicking the close button, pressing a key, or doing nothing. Then we check if event type equals pygameQuit. This is used to detect if the player clicks the close button on the game window. If that happens, we set both game the close equals false and running equals false because now we want to exit both loops, the game over loop and the main game loop, and completely quit the game. Without this for loop, the program won't respond when the player tries to close the window. That's why we write this for loop here, to keep checking if the player wants to close the game while they're stuck on the game over screen. Then we check if the player presses any key. For this, we write if event type equals pygame key down. This means we are watching if the player presses down a key on their keyboard. Inside this block, we write another check. If event.key equals pygame.k.q, here we are checking if the Q key was pressed. Q is for quit. So if the player presses Q, we set game, close equals false, and also running equals false. This will exit both the game over loop and the main game loop, and the game will close completely. We do this to give the player a clean way to quit the game using just the keyboard. That's why we check this here, so the player doesn't have to click the Windows close button. They can simply press Q and the game will stop. Then we check if the player presses the C key by writing if event.key equals pygame.k dot C colon. The letter C stands for continue or play again. If this key is pressed, we want to restart the game from the beginning. So we reset all the important game values. First, we set the position of the snake to the center of the screen again by writing x1. y1 equals 320, 240. Then we stop its movement by setting both x1 change and y1 change to 0. After that, we clear the old snake's body by making snake's list equal to empty, and we also reset its length back to 1 using length of our snake equal to 1. We also move the food to a fixed new location using food x equals 300 and food y equals 200. And finally, we set game dash close equals false so that the game over screen disappears and the main game loop continues. This way, the game starts fresh, just like we launched it the first time. Now it's time to run our full-featured snake game. First, we see the game over screen with the message, and we press the C key to start the game. When we press C, the game resets. The snake appears, the food appears, and the game begins fresh. Here you can see the snake is moving, and we can easily control it using the arrow keys. When the snake touches the red food, it eats it and grows longer each time. Everything is working just as expected. Now, let's test what happens when the snake collides with the wall. We move it toward the edge, and as soon as it hits the wall, boom, the game stops and we see the game over message again. This means the game has correctly detected the collision and entered the game close loop. Now we press the Q key to quit the game. As soon as we press Q, the game window closes and everything stops. So now we know that all features start, grow, collision, game over, play again, and quit are working perfectly. So this is a simple and perfect example of how easily we can build a game using Python with the Pygame library. See you in the next lecture.